Good morning. So today I recommend before you even start, just pause this video and practice drawing our library of functions, okay? So if you want, you can just do that on scratch paper or whatever. I kind of mixed them up here and we're just practicing drawing them, okay? So once that's done then, we'll move on to our notes here. So today we're talking about transformations, which if you remember from geometry, it's when we move around the shape, okay, or the function or whatever it is. Okay, so in our case today, it's a function. So if we have like a parabola, we're shifting it left, right, up, down, flipping it, stretching it, compressing it, whatever the case. So our vertical shift, if it's up, then it's going to be a plus. If it's down, it's going to be a minus. So if we look here at this example, x squared plus 5, this is a parabola that would be shifted up from the parent function. So that's up 5. Now, sometimes we might not even know what the function is, like f of x minus 3. This whole function, whatever it is shifted down 3. Now, sometimes we move left and right, and this is if it's inside of our parentheses. So in this case, left or right. Now, it kind of goes the opposite of what we might expect. So for us to go left means there's plus something. If it's right, it's going to be minus something. So x plus 2, this would cause it to go left 2. F of x minus 6 would be right 6. All right. Now sometimes instead it will flip or reflect. Okay, so if it's going to flip over the x-axis, then that would be when it is just out front, the negative sign, negative f of x is over the x-axis. If it's within the parentheses, then that causes it to reflect over the y-axis. Now, some of these are symmetric over the y-axis, so that won't actually change how it looks, but it technically has occurred. So for example, the quadratic or the parabola, when it reflects over the y-axis, it won't actually look any different. So over the x-axis, over the y-axis. Same thing, x-axis, y-axis. All right, and finally, it will either stretch or compress if there is some sort of leading coefficient. So if that value there is greater than 1, then so if a, whatever's in front, is greater than 1, it will stretch, and it will compress or squash it if a is less than 1. All right, so y equals 3x squared, so it'll cause it to stretch. Half x squared will cause it to compress. Once again, 2 out front will cause it to stretch, and 1/3 will cause it to compress. All right, now down here it says for each function describe the transformation. So we look here, x plus 1 squared, if that's inside the parentheses, it's going to be either left or right, plus 1, so that is going to cause this to go left 1. Every point on it will move left 1 compared to our original parent function, which was y equals x squared. Okay, now on our next one, it's going to flip. Because it's inside of it, it will flip or reflect over the y-axis, which, as we said, for the quadratic, won't actually change how it looks. Okay, number 3, several things are happening. It's going to stretch with a multiple of 2 there, and x plus 3 inside, so it's going to shift left 3. All right, number 4, it will move up 4, because the plus 4 at the end, and it will flip on the x-axis. All right, number 5 will compress. because of that 1/2. It will move down 7 and left 3. So most of these we are used to, they started at 0, 0, so left 7, or down 7, left 3, and -3, -7 is where it would start. Final one here then, it's going to flip over the x-axis. It's going to be up 1 and left 8. All right. And maybe one way we see what we're trying to talk about here, on the delta math, there'll be something like this. So our original function here was y equals the square root of x. And that's graphed right here in black. Now, if we want that to end up over here, I can change some things. For example, if I flip that, do you see how it flips it down over the x-axis? I don't want that, though. I still want it to have the same shape, but I need it to shift left 4. So if it's left 4, when it's left, remember we make it positive. So I'll put +4. And I hit enter, and do you see how it shifts over? Now we want it to go up 3. So if I do -3, it shifts down. That's not good. But if I do +3 and hit enter, do you see how it shifts up and it matches up? Okay, so some of these we'll do today. Let's see, here's one more. We haven't had one like this, but we know the original was in black here. We need it to flip. So I'll change that to negative. Now I need it to move to the right. So if I do right, it's going to be negative, say -3. Does that match up? Oh, not quite far enough. So -4. And then we need it to go down. So negative, what is it, 6? All right. And we are done. So we'll practice that. You'll have some time in a little bit. So now, tell the shape, the rule, and the transformation. When I say, I don't know what I meant by that. Just tell me, is it what the name of the parent function is and then how it moves. So on this first one, y equals, that's going to be square root. And it's going to move left 3. Okay, next, absolute value. It's going to move up 8. And it's going to flip on the x-axis. Or I guess I should say over the x-axis. And then it's also going to be stretched because of that 5. Okay, number 9. This one's maybe harder to remember, the reciprocal function. It's going to go down 5, and it's also going to be flipped over the x-axis. All right, number 10, quadratic. This one only moves a little bit, just down 2. Number 11, it's going to be a square root. It's going to go down 1 and flip over the x-axis. And finally, the last one is a cubic, and with that negative inside, it will flip over the y-axis. And with the cubic, that will actually change some things. Now, we're finally going to put this all together and see what we mean by this. So, do the same thing for 13 and 14, but now we're going to graph them. So this first one, it's a reciprocal, which if you don't remember, the original reciprocal looks something like this. Okay, now ours is going to be shifted left 4. I know that because of the x plus 4 in here. So if you're not sure how you could get that, if you forgot, just think about what value could I not have in there. So x could not be -4 because -4 plus 4 becomes 0. I can't have that. So at -4 here, 1, 2, 3, 4, This line is where it cannot exist. Okay, so now, if I plug in, I want to think of that as my new 0. So I want to make it nice for myself. So I'll move 1 each way, maybe 2 each way, whatever. So 1 to the right of that is at -3. If I plug in a -3 there, -3 plus 4 is 1, 1 over 1. All right, that's nice. Then I put in a -2. That's going to give me 1/2. I could keep going. It's going to get closer and closer. Remember, if I go -3.5, I'm going to get 1 over 0.5, which becomes 2. And we've already graphed this. It gets closer and closer to that. Likewise, closer and closer to the x-axis, never touching either one. Now, sometimes I might go on the other side, or I need to. So instead of -4, I'm going 1 more. So at -5, then it's going to be 1 over -1, so that's -1. -6 gives us -1/2. Likewise, -4.5 will give us -2 right here. Once again, it gets closer and closer and closer. And we are done. All right, the final one, hopefully you can see this is a cubic. It's going to go right 5, up 1. So if we think about this, the normal one was something like this. So that's just going to get shifted over. Normally we start at 0, 0. Instead, right 5, so 5 up 1. So if I plug in a 5 here, right 5. 5 minus 5 is 0. 0 cubed is 0 plus 1. So 5, 1. Do you see how right 5, up 1, that's where we start. Now from there, remember we normally go 1 on each side. So 6 and 4. 6 minus 5 is 1. 1 cubed is 1. 1 plus 1 is 2. Meanwhile, 4 minus 5 is -1. Cube that, -1 plus 1 gives us 0. We'll go 1 each way further, so 7 and 3. 7 minus 5 is 2. 2 cubed is 8. 8 plus 1 is 9. And likewise, 3 minus 5 is -2. Cubed, -8 plus 1. So -7 here. And we draw that in. You see how it's the same shape as the parent function, just shifted over. All right, so go ahead, get into Delta Math, finish up the Delta Math for today, or start and finish it. Hope you guys have a great day. If you have any questions, please reach out, and I'll talk to you later. Bye.